Hi, my name is Yui. I'm a Vietnamese engineer, and today I want to introduce you to something really interesting I've been researching for 2 years and prototyping for 6 months. This is a fully 3D printed processes with computer visions and biosignals, all controlled by Arduinos and Raspberry Pi. The project targets at affordabilities, functionalities, and was made open source for anyone in need.
Phương is the victim of Agent Orange in Vietnam. After seeing her, I was determined to create something useful, given that she has been able to do so much by herself. Initially, I create a body power prosthesis to learn how to design the human hand. But this is not enough for Phương, and I was afraid that the prosthesis would eventually become a burden to her. So I pushed myself to research and create a myoelectric sensor, hoping that this would provide me with more options for future design. The sensors allows Thu to manipulate a prosthesis hand, either open or closed it. With the success of the sensors, I went on and enhanced the functions of the hand to be able to interchange between different grip buttons. I made a simple serial controller for Thu to set her desirable hand buttons, as well as for me to calibrate and debug the systems when needed. Then I create the wrist and the elbow in a modular approach, hoping that the maintenance would be easy and that the system could grow with Thu when she becomes an adult. The entire process is functionally tested, parts by parts, to make sure that everything is working and that it is safe to be used. I also create a visual software for Thu and her family to easily change the set of hand grips already embedded within the processes. With the first versions of the processes finalized, I realized how bad my design was, and I continued to create the next versions of the processes. This new iteration overcomes all the mechanical limitations of the previous versions and make use of 3D printing more effectively. Changing the hand grips could be time-consuming, so I have an idea of using computer visions to both control the wrist and choose the best grip patterns based on the objects to be grabbed. The processes turns out great, weigh less than 1 kg and packed with numerous functions. The fingers are driven separately, the thumb has 2 degrees of freedoms, and the wrist responds well with activation system embedded. The system functions in real time and would lock itself when there is no control signals to save power and safer to wear. But I also want to give Thu more options, so I experiment brain signals, starting with alpha signals from the visual cortex. I wrote several applications to record and analyze the brain signals during my learning curve. The user could use alpha signals to trigger the open and close command to the hand modules once the computer vision has determined the desirable grip buttons to use. I also test my brain-computer interface with SSVEP. Here is the full process of detecting the objects, controlling the wrist, and range checking before closing the hand. Computer vision is hosted with a server so that in the future, the model for object recognition could be easily updated and improved.
As of today, all of the basic functions have been finalized. I've already shown Thu and her family the arm and let her play around with it. And the next step right now is to make it more robust and safer to wear before doing an actual field trial. Just for that, I've already planned for the next design iterations with better mechanical design, housing, and better and more effective biosignal sensors. But just for now, thank you for your listening, and I hope that my project will bring about a positive impact to the community.